It's quite an important one. Well, they're all important, of course, but let's think about another function of the liver. And the one I want to think about now is ketogenesis. The liver will produce ketones. And this happens particularly under the influence of the hormone glucagon released from the alpha cells in the pancreatic islets of Langerhans. Now, in individual liver cells in the hepatocytes, there's lots of individual liver cells. And the individual liver cells have very large amounts of mitochondria, hundreds or maybe 1,000 or more per cell, with these mitochondria with their highly infolded inner membranes. And these are the powerhouses of the cell, where internal respiration and energy production goes on. So the liver cells contain many mitochondria. They contain lots of mitochondria. Now, if blood sugar levels drop, that's detected by the alpha cells of the pancreatic islets. And in response to this hypoglycemic stimulus, they will produce glucagon. And glucagon will do various things. So to begin with, for example, glucagon will facilitate gluconeolysis, breaking glycogen down into glucose. But we only store enough glycogen for a few days of starvation. After that, when the glucagon has caused the glycogen to be released into glucose and we've used that up, we've run out of glycogen then we need other processes. And in that case, the glucagon will stimulate ketogenesis when blood sugar levels are low, for example, as occurs in starvation. So when there's metabolic activity in the mitochondria, in the absence of glucose, then ketones will be produced. So ketones are produced when there is low levels of glucose inside the individual hepatocytes. And what the individual hepatocytes will do is they will take in fatty acids and some ketogenic amino acids, but largely fatty acids. And the fatty acids will be converted in the liver, and the hepatocytes will produce huge amounts of these ketones. So the vast majority of ketones that occur in the blood in starvation have been produced by the liver cells. And these ketones have been traditionally referred to as ketone bodies. This is just a historical term, ketone bodies. But there's actually three of them. There are actually three chemicals. So there's beta hydroxybutyrate, that's that one. There's acetoacetate, and there's acetone. And of course the acetone is the one which is very volatile, and you can smell that on the breath of someone who's ketotic. So that ketotic smell you get is largely from the acetone. And the beta hydroxybutyrate and the acetoacetone, these are both acidic. So when there's a lot of ketones, that's often associated with a reduction in pH in the blood, with a relative acidosis. And if the ketoacidosis is severe, then the normal blood buffering systems can be overcome and the pH can actually drop, resulting in an actual acidosis, meaning that patient is very sick, of course. And we largely associate this with diabetes. So ketosis and the release of ketone bodies will occur in starvation, for the simple reason that these are able to be used by the cells of the body to produce energy instead of glucose. So the brain, over time, the heart, the skeletal muscles can all use the ketone bodies as their energy substrate, as an alternative to glucose. Now, of course, we stress that the brain must have a constant supply of glucose, and that's true. But over time, the brain can adapt to use more ketone bodies and relatively less glucose to supply its energy. But it does take time to facilitate that adaptation, but it does happen. So the ketone bodies are the body's emergency fuel supply. And of course, these can carry on being produced as long as we've got a few proteins left and some fatty acids. And of course, how long they're going to last for depends how many fats are stored in the body. But fats from all over the body can be mobilized, go to the liver cells, undergo this process of ketogenesis by being stimulated by glucagon, which stimulates this process, resulting in the production of these ketone bodies, which we can use as energy. But of course, the irony in diabetes is that there's lots of glucose in the blood, but that glucose in diabetes can't get into the individual cells. So in diabetes, the glucose is in the blood, plenty of glucose in the blood, but you need the insulin to transport the glucose into the cells. Without the insulin, the glucose stays outside the cells, while the mitochondria are without glucose. They're within the cell, but they're without glucose. And that's what causes ketogenesis, if there is insulin lack. So the irony is the patient can be actually hyperglycemic, but still ketogenic. Whereas in starvation, what I guess you could say this mechanism is designed for is the patient will be hypoglycemic, very low on sugar, so the body is making the ketones as an alternative emergency fuel supply. Quite amazing the way the body is designed to survive, and the liver can facilitate that process via ketogenesis.